Hi everyone, welcome to the course on chemistry. In that we are discussing about electrochemistry. In previous video, we have studied how to calculate the electrode potential for any cell at any concentration. And we have seen one of the example to find the standard electrode potential value at any concentration is Daniell cell. That can be calculated by using one of the important equation that is known as Nernst equation. So by using Nernst equation, we can able to find the electrode potential value for any cell at any concentration that we have seen in previous video. So in today's video, we are going to deal with the equilibrium constant from Nernst equation. What is the value of equilibrium constant which is obtained from Nernst equation that we will study. So here, if the circuit in a Daniell cell is closed, then we note that the reaction Zn plus Cu plus 2 gives Zn plus 2 Cu. Means Zn is a solid. Zn solid form olagirutte. It will loses the electrons, means it will oxidizes and gets converted into Zn plus 2. And Cu plus 2, which is present in aqueous form, will gets reduced to Cu. Okay, so this is the reaction which takes place, and if it is closed, and now it will run continuously for a period of time, but after that it will reaches the equilibrium, means there is no loss or gain of electrons will takes place after reaching certain time. So there we can give the equation like this, that is EMF of the cell is equal to 0, means no EMF or voltage is produced when the circuit reaches the equilibrium, and hence it is nothing but E0 cell minus 2.303 RT divided by 2F log Zn plus 2 divided by Cu plus 2. This is how we can write the equation. Since E cell is 0, we will take the standard electrode potential at this side, and we can write it as E0 cell, that is standard electrode potential, is equal to 2.303 RT divided by 2F log Zn plus 2 divided by Cu plus 2. This is for Daniell cell. Okay, now but at equilibrium, the concentration of the Zn plus 2 and Cu plus 2 will remain constant, and hence that constant is said to be equilibrium constant, that is given as Kc. Equilibrium reach ಆದಾಗ Zn plus 2 ions the concentration ಮತ್ತು Cu plus 2 ions the concentration ಏನಿರುತ್ತೆ ರೀ, ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. Upon taking the ratio also, they will gives the constant value, and that is known as equilibrium constant, which is denoted as Kc. Now at temperature T, okay, when it is 298 Kelvin, the above equation can be written as, ಈಗ ಟೆಂಪರೇಚರ್ ಸಪೋಸ್ 298 ಕೆಲ್ವಿನ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರ, ಅವಾಗ ನಾವು ಈ ಮ್ಯಾಲಿನ ಇಕ್ವೇಶನ್ ಯಾವ ರೀತಿ ಬರೀಬಹುದು, E0 cell is equal to 2.303 into R means 0.0821 into T, that is temperature. So what it gives, 0.059 V divided by 2, okay, log Kc, that is equilibrium constant, that is equal to 1.1 volt, because we know that standard electrode potential obtained for Daniell cell will be 1.1 volt. Okay, so E0 cell is equal to ಏನಂತ ಹೇಳ್ತೀವಿ ರೀ, 1.1 volt ಅಂತ ಹೇಳ್ತೀವಿ. Now log Kc, we need to find the equilibrium constant. So log Kc I will write here, and upon cross multiplying I will get 1.1 into 2 divided by 0.059 V is equal to 37.288. And now we want Kc. So take the log at this side, it will becomes anti-log. So anti-log of 37.288 will gives 2 into 10 raised to 37 at 298 Kelvin. This is for Daniell cell. Equilibrium constant obtained from Nernst equation for Daniell cell will be 2 into 10 raised to 37 at this temperature. In general, if we want to calculate the equilibrium constant from Nernst equation for any other cell, we will use the equation 2.303 RT divided by NF log Kc. Okay, so by using this equation, we can calculate the equilibrium constant for any given cell. Okay, so this is about the equilibrium constant from Nernst equation. Next, we will move to the another concept, that is electrochemical cell and Gibbs energy of the equation. So here, if the EMF of the cell is E, okay, and NF is the amount of charge passed, and Gibbs energy of the reaction is delta Rg, then we can write it as delta Gr, that is Gibbs energy of the reaction, is equal to minus NF E0 cell. Okay, where N is number of moles of electrons, F is Faraday's constant, E0 cell is standard electrode potential. Okay, this is how we give the equation. Then here E cell is an intensive parameter. Intensive means it is independent of amount of the substance or ions present in the solution. But delta Gr, that is Gibbs energy of the reaction, is an extensive thermodynamic property. Extensive thermodynamic property means it is dependent on amount, okay, or mass or quantity of matter, and the value depends on N. ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ ಇದು n ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ, number of electrons. Okay, thus we can write the equation Zn plus u plus 2 gives Zn plus 2 plus u. This is the equation of Daniell cell. We can write it as delta Gr is equal to minus 2 F E0 cell. Okay, because n means number of electrons that is involved in the reaction, and hence we have written it as 2. And when we write the equation like this, ee riti equation baradre anta helidre, okay, when we consider 2 moles of the Zn, 2 moles of Cu2 and 2 moles of Cu, then we can write it as minus 4 Fe. Okay, so as number of electrons and number of moles of electrons changes, the value of delta Gr, that is Gibbs energy of the reaction, will also changes. Okay, so if the concentration of all the reacting species is unity, then if suppose ella reaction nadibekadre reactants the concentration ಏನದ ಯೂನಿಟಿ ಅದ ಅಂತ ಹೇಳಿ ತಿಳ್ಕೊರಿ, 1 ಅದ ಅಂತ ಹೇಳಿ ತಿಳ್ಕೊರಿ. ಅವಾಗ ಈ ಸೆಲ್ ಯಾವುದಕ್ಕೆ ಈಕ್ವಲ್ ಇರುತ್ತೆ ರೀ? E0 ಸೆಲ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ವ್ಯಾಲ್ಯೂಗೆ ಈಕ್ವಲ್ ಇರುತ್ತೆ. And thus we can write delta Gr is equal to minus NF E0 cell. So here E0 cell is standard electrode potential and delta Gr is standard Gibbs energy of the reaction. It is when the reacting species having the concentration 1 or unity. Okay, so remember this equation, very important. Based on this you will also get problems. Okay, so this is about electrochemical cell and Gibbs free energy of the reaction. Then here measurement of E0 cell, we can obtain an important thermodynamic quantity, that is the standard Gibbs energy of the reaction. So by using this we can calculate the equilibrium constant also. Now ಈ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಗಿಬ್ಸ್ ಎನರ್ಜಿ ಆಫ್ ದಿ ರಿಯಾಕ್ಷನ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು? equilibrium constant ಅನ್ನು find out ಮಾಡಬಹುದು, and that is calculated as delta gr naught is equal to minus RT ln K, where again K is equilibrium constant. So remember this equation. This is the equation which is used to calculate the equilibrium constant when the Gibbs energy reaction is given. Okay. Now, conductance of electrolytic solutions. How does the electrolytic solutions conduct the electricity, and how we can measure the conductance of those solutions, that we will study. So first one, you should know what is conductance means. Conductance, it is denoted by G, and it is the reciprocal of resistance and defined as the ease with which the electric current flows through a conductor. ಎಷ್ಟು ಸರಳವಾಗಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಕಂಡಕ್ಟರ್ ಥ್ರೂ ಪಾಸ್ ಆಗುತ್ತೆ ಅದನ್ನು ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ, ಕಂಡಕ್ಟನ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ, and it is denoted as capital G. And the SI unit is Siemens. SI unit entry Siemens, and 1 Siemens is equal to per ohm or mhos, or it is indicated as per ohm by this symbol. Then another term is conductivity. Conductivity means it is an electrolytic solution which can be defined as the conductance of a solution of 1 centimeter length with area of cross section equal to 1 square centimeter. Suppose ಆ solution ದ conductance find out ಮಾಡಬೇಕಾದ್ರೆ 1 centimeter length ಇತ್ತು ಮತ್ತು ಏರಿಯಾ ಆಫ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ 1 ಸ್ಕ್ವೇರ್ ಸೆಂಟಿಮೀಟರ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಅವಾಗ ಆ ಸೊಲ್ಯೂಷನ್ದ ಕಂಡಕ್ಟನ್ಸ್ ಎಷ್ಟಿರುತ್ತೆ ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಕಂಡಕ್ಟಿವಿಟಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಸೊ ಯೂನಿಟ್ ಲೆಂತ್ ಆ್ಯಂಡ್ ಯೂನಿಟ್ ಏರಿಯಾ ಆಫ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಆ ಸೊಲ್ಯೂಷನ್ದ ಅವಾಗ ಕಂಡಕ್ಟನ್ಸ್ ಎಷ್ಟಿರುತ್ತೆ ಅದನ್ನು ನಾವೇನು ಹೇಳ್ತೀವಿ ರೀ, ಕಂಡಕ್ಟಿವಿಟಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಗಿವನ್ ಆಸ್, ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ಸೇಡ್ ಟು ಬಿ ರೆಸಿಪ್ರೋಕಲ್ ಆಫ್ ರೆಸಿಸ್ಟಿವಿಟಿ, and it is denoted as kappa. Okay, small k ಅಂತ ಇದಲ್ಲ, ಇದಕ್ಕೆ ಏನಂತ ಹೇಳ್ತೀವಿ, ಕಪ್ಪಾ ಅಂತ ಹೇಳ್ತೀವಿ. And 1 divided by rho, that is reciprocal of resistivity, and here it is also written as 1 divided by R into L divided by A, because resistance again it is given by L divided by A, that is equal to G into L divided by A, because 1 by R is what, conductance, that here already given. So G into L divided by A. Now if L is equal to 1 centimeter and A is equal to 1 square centimeter, length is 1 centimeter and A is 1 square centimeter, then it is K is equal to G, that is conductivity becomes equal to conductance. That I have already defined here. ಅದನ್ನು ಡಿಫೈನ್ ಮಾಡಿನಿಲ್ಲ, 1 centimeter length and area of cross section 1 square centimeter ಇದ್ರೆ ಅವಾಗ ಕಂಡಕ್ಟನ್ಸ್ ಎಷ್ಟಿರುತ್ತೆ ಅದನ್ನು ನಾವೇನು ಹೇಳ್ತೀವಿ, ಕಂಡಕ್ಟಿವಿಟಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ದೆನ್ ನೆಕ್ಸ್ಟ್ ಒನ್, ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ. ಸೊ ಫಾರ್ ಸೊಲ್ಯೂಷನ್ಸ್ we will use the term molar conductivity instead of using conductivity, because here we take the solutions and the concentration is measured in terms of molarity. So if they are measured in molarity, it is said to be molar conductivity. So what does this molar conductivity means? It is defined as the conducting power of all the ions produced by dissolving 1 mole of an electrolyte placed between 2 large electrodes at 1 centimeter apart. ಯಾವುದೋ ಒಂದು ಸೊಲ್ಯೂಷನ್ ತೊಗೊಂಡಿರಿ, ಆ ಸೊಲ್ಯೂಷನ್ ಒಳಗೆ ಅಯಾನ್ಸ್ ಇರ್ತಾವೆ, ಆ ಎಲ್ಲ ಅಯಾನ್ಸ್ ದ ಕಂಡಕ್ಟಿಂಗ್ ಪವರ್ ಎಷ್ಟಿರುತ್ತೆ, ಓಕೆ, ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಆ್ಯಂಡ್ ರಿಮೆಂಬರ್, ದಿ ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಈಸ್ 1 mole. 1 mole ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಡಿಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಅವಾಗ ಆ ಎಲ್ಲ ಅಯಾನ್ಸ್ದು ಕಂಡಕ್ಟಿಂಗ್ ಪವರ್ ಏನಿರುತ್ತೆ. ಆ್ಯಂಡ್ ದಿ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಆರ್ ಸಪ್ರೇಟೆಡ್ ಬೈ 1 centimeter ಅಪಾರ್ಟ್. ಓಕೆ, 1 centimeter ಬಿಟ್ಟು ಇರ್ತಾವೆ ಡಿಸ್ಟನ್ಸ್. ಓಕೆ, and it is given as lambda m is equal to kappa into V. Kappa means conductivity, into V means volume. So it is also given as lambda m is equal to kappa into 1000 divided by C, because volume of the solution in cubic centimeter containing 1 mole of electrolyte, and C is the molar concentration. So as we know, molarity is nothing but what? The number of moles of solute dissolved in 1 liter of solution. Okay, by substituting that equation we will get K into 1000 divided by C. So remember this expression to find the molar conductivity. Okay, and here the unit of molar conductivity is per ohm square centimeter per mole, or Siemens square centimeter per mole. This is the unit of molar conductivity. Then suppose if the concentration of the solution is measured in terms of normality use ಮಾಡಿದ್ರಿ ಅಂತ ಹೇಳಿದ್ರ, ಅವಾಗ ನಾವು ಕಂಡಕ್ಟಿವಿಟಿಗೆ ಏನಂತ ಹೇಳ್ತೀವಿ? ಇಕ್ವಿವ್ಯಾಲೆಂಟ್ ಕಂಡಕ್ಟಿವಿಟಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಇಟ್ ಈಸ್ ಡಿಫೈನ್ಡ್ ಆಸ್ conducting power of one equivalent of electrolyte placed between two large electrodes at 1 centimeter apart. And here it is given as again kappa into V. Okay, so equivalent conductivity is kappa into 1000 divided by N. Illi N use ಮಾಡ್ತೀರಿ. Okay, and V is volume again, and one equivalent electrolyte is there, and N is normality, and the units is per ohm square centimeter per equivalent, or Siemens square centimeter per equivalent. So this is the equivalent conductivity. So this is all about the conductance of electrolytic solutions. ಇವೆಲ್ಲ ಏನ್ರಿ ಜಸ್ಟ್ ಕಂಡಕ್ಟಿವಿಟಿ ಮೇಜರ್ ಮಾಡಕ್ಕೆ ಡಿಫ್ರೆಂಟ್ ಟರ್ಮ್ಸ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಆ ಒಂದಿಷ್ಟು ಟರ್ಮ್ಸ್ ನಮಗೆ ಏನು ಮಾಡಿದ್ದಾರೆ ಇಲ್ಲೇ ಕೊಟ್ಟಿದ್ದಾರೆ. ಓಕೆ, ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆ್ಯಂಡ್ ಇಕ್ವಿವ್ಯಾಲೆಂಟ್ ಕಂಡಕ್ಟಿವಿಟಿ. ಮೊಲಾರಿಟಿ ಕೊಟ್ಟಿದ್ರ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ, ಈಗ ನಾರ್ಮ್ಯಾಲಿಟಿ ಕೊಟ್ಟಿದ್ರ ಇಕ್ವಿವ್ಯಾಲೆಂಟ್ ಕಂಡಕ್ಟಿವಿಟಿನ ಏನು ಮಾಡ್ತೀವಿ? ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಬಿಕಾಸ್ ಹಿಯರ್ ದಿ ಸೊಲ್ಯೂಷನ್ಸ್ ಆರ್ ಪ್ರೆಸೆಂಟ್, ಹೆನ್ಸ್ ವಿ ವಿಲ್ take the equivalent and molar conductivity. If a solid substance is there, then we simply use conductivity. ಏನಾದರೂ ಸಾಲಿಡ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಕಂಡಕ್ಟಿವಿಟಿ ಅಂತ ಹೇಳಿ ಯೂಸ್ ಮಾಡ್ತಿದ್ವಿ. ಬಟ್ ಸೊಲ್ಯೂಷನ್ ಇರೋದ್ರಿಂದ ಅಲ್ಲೇನು ಮಾಡ್ತೀವಿ? ಈ ಡಿಫ್ರೆಂಟ್ ಕಂಡಕ್ಟಿವಿಟೀಸನ್ನು ನೋಡ್ತೀವಿ.